All right, everybody, we're going to keep on moving on here. We're in Savas Algebra 2, working on topic or lesson 7-3, topic 7, trigonometry. And problem number 5 that I've asked you to do. So we are looking at problem 5, the tangent of an angle. So now we got that pi in there. So we have some radian work to do here. If you need a little refresher on that radian quick. Unit circle, if you will, all the way around 2 pi. Why? Because of radian itself. Hopefully you're getting this by now. We've talked about it lots. Of radian, if you take the radius, lay it on the circle like it's a string, that same length r there, this angle here is your radian. And how many of those would there be going around the circle? Every time you laid one on here, we'd have another radian. And because circumference equals 2 pi r, there are 2 pi of the radians when you go around of these radii. There's 2 pi of them, so all the way around is 2 pi. That's where it comes from, at least for me to remember it. And so halfway around would be a pi from, we always start here, the initial side right there. So right up here, that would be halfway to pi. So pi over 2, we usually write that, etc. So we've got 31 pi over 6. So just a reminder, if we went all the way around, if 2 pi is a full rotation, then 12 pi over 6 reduces to 2 pi. And I'm using that because we've got pi over 6's here. So every time we do a 12 pi over 6 rotation, that's a full rotation. So let's see where we're at on the unit circle if we just take that out, because 24 pi over 6, that would be like 4 pi, right? So you reduce that, that would be 2 full rotations since 12 pi. So if we take that 24 pi over 6 out of the 31 pi over 6, the 2 rotations, see what's left. 31 minus the 24. If I'm not mistaken, that's 7 pi. 31 minus 24. 24 plus 7, we get back to 31. 7 pi over the 6. And where is 7 pi over 6? So that, I'm thinking of it as a 6 pi over 6. That's 1 full pi. And so that would be like a full pi. I'd end up right there, but I gotta go another pi over 6. So it's right in there, right over there. A pi over 6 past a pi over 6 past my pi. So there's my reference triangle I'm talking about. That angle in there was like a pi over 6. Pi over 6, remember, was a 30-degree angle. And so from my 30-degree angle, here's my 1/2, or hypotenuse 1. The long side, square root of 3 over 2 on the 30, 60, 90 with radius of 1 there. And they're looking for tangent. So tangent, TOA. Remember, TOA, opposite over adjacent. So the opposite side from that 30-degree angle is the 1/2. And the adjacent side is the square root of 3 over 2. Here we went left, so that's negative, and we went down, that's negative. So it's negative over negative, so it will be a positive. Instead of dividing by this, I'm going to multiply by the reciprocal up here. And what happens to those 2's? I've got one of them that I'm dividing by a 2. One of them I'm multiplying by a 2. So I've got a 1 over the square root of 3. Rationalize that denominator. Now, many places don't like those down there, so a few will let you leave it there, but just so you remember how to do that in case you're required to, and Savas wants it this way also. So square root of 3 over 3 for our tangent. Unless I botch things up again, if you watched the last video, you saw me spend about 5 times the amount of time I should have on it because I didn't read the full directions. This one didn't have much for directions, so I think we're okay here. Got a fraction, we got a square root up there. I've got a 3 in the numerator under the radical and a 3 in the denominator, and I think we should be good to go. So there you have it. No mistakes that time. Good luck, stick with it. Look for other resources if you need to. Rotations on in radians on the unit circle with trig functions is what I would search for. And you will figure this all out. All right, have a great day, everybody.